and welcome to NPTEL project on econometric modeling. This is Rudra Pradhan here. Today we will discuss the concept of univariate econometric modeling. First of all, what is univariate econometric modeling? It is a statistical analysis that considers only one factor or a variables at a time. It explores each variable in a data set separately and is very essential for multivariate analysis. So, univariate modeling is an essential condition for multivariate modeling. Univariate modeling also called as a descriptive statistics. It is concerned with the description or summarization of individual variables in a given data set. So, let me explain what is all about this univariate econometric modeling. Let us take a case here. We have series of variables x 1, x 2 up to x n, y 1, y 2 up to y n, all right. So, this is what is all about multivariate framework of econometric modeling. So, here we are very much concerned about the statistical analysis of a particular variable or series of variable and their interrelationships. So, if we go through this multivariate framework of econometric modeling, then usually we have two different sets of variables. Okay. One set of variables is called as a x 1, x 2 up to x n, and another set of variables are called as a y 1, y 2 up to y n. Okay. This particular series called as a independent variable clusters, independent variable cluster, and this particular series y 1, y 2, y n is called as a dependent variable clusters. So, multivariate framework or multivariate econometric modeling is nothing but the structure of or integration of independent variables and dependent variables. So, it is the game between independent variable and dependent variable, otherwise it is also called as a endogenous variables and exogenous variables. There are two different situations altogether. Okay. Situation 1, one dependent variables with several independent variables. So, the situation 1 is one dependent variable with the several independent variables. So, this particular structure is called as a simple multivariate framework, simple multivariate framework, simple multivariate framework or simple multivariate modeling. Okay. Situation 2, where there are several dependent variables plus several independent variables. So, this particular structure is called as a simultaneous equation modeling or and structural equation modeling. Okay? Structural equation modeling. So, we have two different games so far as a real world problem is concerned. So, one side we have one dependent variable with several independent variables. In other situation we have series of dependent variables and series of independent variables. So, now let me take a case here. So, this is independent clusters, this is dependent clusters. Okay. So, we have independent clusters will represent x 1, x 2, x 3, x 4 like x n. All right. Dependent cluster we have y 1, y 2 up to y n. So, now when there is a question of situation 1, then we have to integrate y 1 with x 1s, y 1 with x 2, y 1 with x 3 and so on with y 1 with x n's, or y 2 with x 1, y 2 with x 2, y 2 with x 3, y 2 with x 4 or y 2 with x n. Like we can integrate y 3 with so many independent variables and y 4 with so many independent variables, again y n with so many independent variables. So, this particular framework called as a simple multivariate econometric modeling. However, in the question of structural equation modeling, so the structure is completely different. So, that means here every variable has an integration with the other variables. This is the condition 1 and the condition 2 is there are series of dependent variables and series of independent variables. Okay. So, now within the detailed structures, so we have to discuss here what is all about the univariate econometric modeling. So, univariate econometric modeling is basically represented as here univariate econometric modeling represented as a UEM, univariate econometric modeling. So, let me first highlight here what is the entire structure of this univariate modeling. Okay. So, the basic objective behind univariate modeling is that we have to describe or you have to summarize a particular variable in a given setup. Okay. If the setup consists of say 10 variables, we have to analyze with a particular variable only. For instance, if we have x 1, x 2, x 3 up to x 10, then we like to know what is the features of x 1, what is the features of x 2, what is the feature of x 3 and up to what is the feature of x 10s, because it is the prime requirement of multivariate econometric modeling. Until unless you know all these structure and setup of univariate data setup, then you cannot go anything or you cannot get a better solutions. So, univariate econometric modeling deals with three issues. One is called as a central tendency, then dispersion, then third is called as a skewness or kurtosis. So, what is central tendency? It is the single figure which describes the entire setup. So, the central tendency will give you indication about single figures. Okay. So, like this there are set of observation here. So, we have to target which particular observation is very important, which can describe the entire issue. Okay. The dispersion is within this setup again. So, it represents the variability of the observation in a particular variables. So, let us say this is variable say x 1s. So, now these points are represented as x 11, x 12, x 13 up to say x 1 n, all right. These are the data points with a particular variables. So, now which particular variable is the central, or you can say center, that describes the complete information within the structure or within that particular variables. So, now let us say this is a center here. Let us call it x is a unit which represents the entire structure of this particular variable. So, now dispersion is the variability of the observation in a particular variable. So, now if it is x 6, so now we are very much concerned about how the x 6 component is different from x 3, x 1 1, x 1 2, x 3 1 3 like this. Okay. So, we have to see whether this is equally distributed or unequally distributed, and that objective is the framework of dispersion. Now, the skewness issue is the general shape of the distributions. So, far as the distribution is concerned, we have series of distribution like theoretical distribution. Under theoretical distribution, we have probability distribution, Poisson distribution, normal distribution, hyperprobability distributions, and so on. But for econometric modeling or basically statistical modeling, so the model will be best fitted, or we can use that model, or we can fit that model for better way. Your data points should be normally distributed. So, that means we are very much interested whether the setup is normally distributed or not. So, that means we are very much interested to integrate the structure into normal distribution shape. So, that shape of the distribution is our concern, and that is nothing but the skewness component. So far as kurtosis is concerned, it is the flatness of the distribution, again it is within the setup of normal distribution. Okay. So, now we have three different structure of univariate modeling. So, one structure is the central tendency, another structure is dispersion, and another structure is skewness. The objective is to find out the single figure which describes the entire issue. The second issue is dispersion, how all other items are distanced from other data points. Okay. So, this is what the dispersion objective, and skewness is the shape of the distribution, and kurtosis is the flatness of the distributions. So, now within the basic background or information about univariate setup, so we like to know how this setup can be evaluated, can be interpreted, and can be used further for multivariate econometric modeling. Let me first give you the framework of univariate econometric modeling. So, univariate econometric modeling, as I have already mentioned, it has three different structure altogether: central tendency, then dispersions, then it is a skewness and kurtosis. Okay. Under central tendency, we have three different we have altogether three different setup. Okay. This is called as a mean setup, this is median setup, then this is mode setup. So, we have three different statistical tool under central tendency. Okay. So, this median and mode is called as a positional average, it is called as a positional average. Mean is called as a mathematical average. Mean is called as a mathematical average. So, now similarly for dispersions, we have two things, one is called as a absolute measure, and another is called as a relative measure. Similarly, for the case of skewness, we have two different setup, one is called as a absolute measures and another is called as a relative measures. Okay. So, now we have to see what is the structure of central tendency, structure of dispersion and what is the structure of skewness. So, now under central tendency the objective can be evaluated through mean, median and mode. So, median and mode is represented as a positional average, mean is represented as a mathematical average, on the other side dispersion or variability of the information can be observed in a absolute angle and can be observed in relative angles. Similarly, for skewness and kurtosis we can have the absolute issue and also relative issue. So, now the mathematical average can be again various shapes. Okay. It is represented in 3 different formats: arithmetic mean, geometric mean and harmonic mean. Okay. So, arithmetic mean is or it can be again calculated through simple structure and by assigning weight. Similarly, geometric mean can be calculated with a simple structure and by assigning weight. Harmonic mean can also be calculated in simple structure and by weight. Okay. So, now the structure of central tendency is that we like to know what is the mathematical average and what is the positional average. So, for as dispersion is concerned, we like to know what is the absolute issue, what is the relative issue, or how is the absolute measurement of that particular variable and what is the relative measurement of that particular variable. Similarly, in the case of skewness and kurtosis, we like to know how the shape of the distribution in absolute angle and relative angle. Let me highlight here the central tendency structure first, then we can proceed further for you can say econometric modeling issue. So, now this econometric modeling altogether is this here. Let us see within the central tendency. So, let me first highlight the issue of arithmetic mean first. Okay. Okay, this is mean first, then within the mean, then we have arithmetic mean, we have geometric mean and we have harmonic mean. All right. So, now for arithmetic mean we have again simple average and weighted average. Okay. So, now the simple average is nothing but x bar is equal to summation x I equal to 1 to n divided by n. Okay. So, what is this? So, basically for a particular setup, if we will consider a variable say x, then its information is represented as a x1, x2 up to xn. So, what we will call it? It is otherwise represented as a x I. When I equal to 1, then it becomes x1, when I equal to 2 it becomes x2, when I equal to 3 it becomes x3, like when I equal to n it is xn. So, that means one variable has the n number of information or observation. So, what is the fundamental issue of arithmetic mean? In a simple structure, the fundamental issue is to add all the observations, value of that observation and divide by number of observation. That means, it is nothing but x1 plus x2 plus x3 up to plus xn divided by number of observations. Okay. So, this is what the a simple structure of arithmetic mean. When there is called a weighted average, then x bar is represented as in sometimes it is represented as a x bar w. Okay. So, it is nothing but summation f I x I equal to 1 to n divided by n, okay, where this n represents summation f I equal to 1 to n. So, that means, here w represents weight factors and that weight has to be represented in the form of frequency. For instance, if you take this particular variables x1, x1, x2 up to xn, then corresponding to each variable information x and f, we have frequency f1, f2 up to fn. Okay. So, what is the usual procedure? Now, for weighted average, so we have to multiply with f and x. Okay. So, we will get f1 x1, f2 x2 up to fn xn's. Okay. So, finally, we like to know what is sum of fi xi I equal to 1 to n. That means, so x w is nothing but w1 sorry f1 x1 plus f2 x2 plus fn xn divided by n. N represents sum of fi. Okay, I equal to 1 to n, which is designated as a n. Okay. This is the structure of weighted average. So, weighted average structure is like this, and this is the structure of simple arithmetic mean. So, now let me highlight two things here. One important issue is here the property of arithmetic mean. One of the interesting properties is sum of the deviation of arithmetic mean from its mean is equal to 0. So, that means sum of x minus x bar is equal to 0. Sum of the deviation of item from the arithmetic mean is equal to 0. Okay. Second issue is since x bar equal to summation x by n. So, that implies summation x is always equal to n into x bar. This is for verification only. Third issue is it can be have combined mean. So, x 1 2 bar is nothing but n 1 okay, combined mean. The third important property is here the combined mean. So, third important property is combined. This is nothing but n 1 x 1 divided plus n 2 x 2 divided by n 1 plus n 2. All right. So, now what is all about that issue? That means, let us say there are two variables x 1 and x 2. So, corresponding x 1. So, you have information x 1 x 2 up to x n, you have information x let us take x 1 1 2 1 n 1, then x 2 1 x 2 2 up to x 2 n. All right. Or otherwise we can put like this x 1 1, then x 2 1 x 3 1 up to x n 1. All right. Then similarly, this side we can put x 1 1 x 1 2 x 2 1 2 2, then 2 3 up to x 2 n. Okay. So, now we like to know what is n here. So, that is represented as n 1 and that is represented as x 1. Similarly, this side we like to know what is n 2 and what is x 2, x 1 bar, x 2 bars. So, within n 1 x 1 bar and n 2 x 2 bar we have to calculate the combined mean. So, that is the joint case of the two variables. All right. So, this is what the arithmetic mean with respect to its simple structure and weighted structures. So, now come down to the structure of geometric mean here. Geometric mean can be also calculated with the simple structure and weighted structure. So, now for a series of variables say x, x 1, x 2 up to x n, then geometric mean usually denoted as small g is nothing but x 1 multiplied by x 2 multiplied by x n to the power 1 by n. So, this is what the calculation of geometric mean. Okay. So, now for weighted issue, then we can call it g w, which is nothing but x 1 f 1 multiplied by x 2 f 2 multiplied by x 3 f 3 multiplied by x n f n to the power 1 by n. All right. So, this is the structure of the geometric mean. In the case of harmonic mean, this is also simple structure and weighted structure. So, now in the case of harmonic mean, it is nothing but n by summation 1 by x I equal to 1 to n. Okay. In the case of weighted average, so a harmonic mean with weighted average is nothing but n by summation f I by x I equal to 1 to n. Okay. So, now we get to know what is the setup of mathematical average, that is arithmetic mean, geometric mean and harmonic means. Again that is with respect to simple structure and weighted structure. So, now within this basic setup, within the basic setup of this mathematical average, then you will come down to the positional average. This positional average is with respect to, first is the median case, first is with respect to median case. So, what is this median? Median is nothing but or you can say middle value of the sequence. So, that means once you have a series of observation, the objective of median is you have to find out a particular variable or value which can divide the observation into two equal parts. Okay. 50% means 50% above and 50% below. So, that means, median can be calculated in a simple structure, it can be calculated in simple structure. Under simple structures, the framework is like this, n by 2 provided if n is even, n represents number of observation in the setup. Okay. So, now when n plus 1 by 2, when or if n is odd. Okay. So, this is what the simple structure of median calculation. So, now you remember this median is a positional average. So, now the n by 2 and n plus 1 by 2 will give you the position to describe the issue. So, now for reality or you can say complex problem, the value of median will be calculated like this, L plus n by 2 minus C f by f into I. L represents lower limit of the class, n represents number of observations in the system, C f represents cumulative frequency of the preceding median class, f represents class frequency of median class. Okay. Then I represents class interval. Okay. So, now for whether it is the mean issue, median issue or mode issue, there are two different ways we have to calculate. One is a simple setup, another is called as a discrete or continuous setup. When there is the structure is a very simple structure, then we have to just use the positional issue or you can say simple issue like summation x I by n or n by 2 by or n plus 1 by 2. But when the structure is all about the issue of discrete series or continuous series, then the calculation procedure is somewhat different. So, now median structure is here L plus n by 2 minus C f by f into I. Okay. So, I will give you detailed example how we have to calculate or how you have to use this particular formula when the problem is something different, and you have to apply this particular formula when the problem is something else. Okay. So, now come down to mod issue. So, now mod is altogether, mod is also positional average. It is the value of variable which has highest frequency, value of variable which have highest frequency, highest frequency. Okay. So, now this is again give you the positional issue, this is give you the positional issue, this is give you positional issue when the structure is individual series or simple structure. So, now when there is a discrete series or continuous series, then the mod calculation will be L plus del 1 by del 1 plus del 2 into I. So, del 1 is nothing but f1 minus f0 and del 2 is nothing but f1 minus f2. So, this is f0 represents frequency of the modal class and f1 represents frequency of the preceding modal class and f2 represents frequency of the following modal class. Okay. So, now I represents class interval. So, I represents here class interval. Okay. I represents class intervals. So, now let me take a case here. So, how do you calculate all these issues? Let us take a case examples here. So, now there is a series here. This series it is with individual issues. So, now the examples which we have cited here, we have series of information 52, 76, 100, 136, 186, 196, 205, 150, 257, like this we have to proceed, then we have 791 and 891. So, now our objective is to know what is the mean value here, what is the median value here and what is the mode value here. So, far as a mean is concerned, we like to know what is the value of these observations and what is the number of observations. So, now for simple arithmetic mean, we have to just add all these items, divide by number of observations. So, number of observation you have to find out what are the number of observation here. So, now if you follow that procedure, you can have the mean value. Similarly, for the median issue, so for the procedure of median calculation is that we have to first arrange these items in ascending and descending. So, now the moment you will arrange it ascending and descending, then you have to apply the positional issue. So, that means if the series is even, then you have to apply n by 2, if the series is odd, then you have to apply n plus 1 by 2. So, this will give you indication what is the median of that particular series. So, the way you will calculate that median, then 50% observation will be above and 50% observation will be below. So, now similarly, in the case of mod, so we have to first arrange the items in sequence, then you have to see what is the frequency of each items. So, now mod will be the value of that particular series depends upon the highest frequency. So, with the basis of highest frequency, you have to calculate the mod. For instance, let us take a case of 150. So, 150 item we have to find out whether it is available in other place. So, now if it is available in other place, we have to see how many times. Okay. Similarly, take a case of 196. That means, what is the best procedure is that like this. The best procedure is that you have to see here, take a case of items. So, now these are all items, then its corresponding frequency. Okay, frequency. So, now you check it here 52, all right. Let us take a case of 52. So, now again 76. then 100, then 136, then 186, 196, 205, then 150, then 257, then 264, then 264. So, now if we compare here 76 here sorry 52, this is 1, 76 1, 100 1, 136 1, 186 1, 196 1, 205 1, 151, 257 1, 264 1. So, since it is again 264. So, instead of writing here you put it in mark here. Okay. So, now instead of 264 you put it here 280. Okay. So, now you have to see how many 280s are there. If it is 1 here, then if it is again 280 you put mark here, if again 280 you put mark here, then finally you have to observe how many frequencies are there. Let us say 280 is there. So, this is available in 3 times. So, its frequency is nothing but 3. Here the frequency is nothing but 2. This is 1, 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 this is 1. So, now there may be other series also, but within the particular setup. So, we can call it this is the model class, because it is the highest frequency in the particular series. So, this way we have to calculate the value of mod. Okay. So, now we have to proceed further for other issue of this particular univariate econometric modeling. Okay. So, now univariate econometric modeling, we have the set of central tendency, dispersions and skewness. Okay. So, central tendency we have already discussed what is the structure and how is its set up. So, now so far as dispersion is concerned, we have two different structures. One is called as a absolute structures, and another is called as a relative structure. So, that means absolute measure of dispersion and relative measure of dispersion. Under absolute measure of dispersion, we have series of techniques. Range, quartile deviations, then mean deviations, then standard deviations. Okay. And under relative measure of dispersions, we have 3 different techniques called as a coefficient of variations, coefficients of quartile deviation, coefficients of mean deviations. Okay. Coefficients of coefficient variation, coefficient quartile deviation, coefficient of mean deviation. So, now I will explain what is all about these components. Let us start with range. How do you calculate this range? Okay. Range is the difference between a maximum of the series and minimum of the series. Okay. In this particular example, if you like to know what is the range, then you have to see what is the highest number of this particular series, then what is the lowest value of that particular series, then the difference will give you range. In a econometric modeling, if the range value is very high, then obviously it is the negative aspects of econometric modeling. So, the econometric modeling will be better, or you can get better fitted model if your descriptive information or univariate information is very accurate. For instance, for this particular issue range, if the range is very minimum, that means it automatically give you the spreadness of that particular variables. If the range is very small, then obviously the dispersion is very low. So, that means the variability of that particular variable is, you can say, low. So, it will be better indication for further econometric modeling. So, similarly, come down to quartile deviation. So, quartile deviations is nothing but the difference between Q3 minus Q1 by 2. So, third quartile minus first quartile divided by 2. What is third quartile? So, third quartile we have to get by L plus 3n by 4 minus CF by CF by f into I. Okay. and q1 equal to L plus n by 4 minus Cf by f into I. We have already discussed what is Cf. This is a cumulative frequency of the preceding median class, and f represents frequency of the median class, I represents class interval, L represents lower limit of the series, q3 represents third quartile and q1 represents first quartile. So far as quartile deviation is concerned, so it is calculated with the difference of third quartile minus first quartile by 2. Okay. So now come down to mean deviations. So mean deviation is nothing but 1 by n summation x I minus x bar. Okay. It is in deviation format. So the speciality of this component is that it ignores usually sign. So the moment you will take deviation, then the minus component will be plus component. So as a result, it may be a better for you can say calculation, but it has also limitation because the negative signs are ignoring. So now this is what the procedure of mean deviation. If there is a frequency, then obviously you have to add frequency here, then accordingly you have to calculate the mean deviation. Okay. So now come down to standard deviation. Standard deviation is nothing but summation x I minus x bar whole square I equal to 1 to n to the power 0.5. This is the calculating procedure of standard deviations. Okay. So now you get to know what is range, what is quartile deviation, what is mean deviation, what is standard deviation, and I am just explaining the simple structure, that is with respect to individual series. So when the series is continuous and discrete, then obviously the calculating procedure of all these components starting from central tendency to dispersion is completely different. Though there is lots of integration or similarity, but the only the problem is the calculation procedure. So now standard deviation is basically the square root of this, you can say sum of the observations from its central point. Okay. So now come down to relative measure of central tendency. Under relative measure of central tendency, the first standard technique is called as a coefficient variation. Coefficient variation is simply represented as a sigma by x bar multiplied by 100. Sigma usually represented as a standard deviations. Okay. The square of standard deviation is called as a variance. Okay. So now come down to coefficient of quartile deviation. So coefficient of quartile deviation is calculated with respect to median. So now quartile deviation divided by median multiplied by 100 will give you coefficient of quartile deviation, then some coefficient of mean deviation. So coefficient of mean deviation is nothing but mean deviation about mean with respect to mean or median, mean deviation by mean multiplied by 100. This is coefficient of mean deviations. Okay. So now this is the calculating structure of the relative measure of standard deviations. So we have complete information how to calculate the absolute measure of dispersion and how to calculate the relative measure of dispersion. So the important difference between the absolute measurement and relative measurement is that in the first case the structure is not unit free, but in the second case the structure is completely unit free. So that is why relative measure of dispersion is the best measure than the absolute measures. So now so far as the technique wise concept is concerned, so in the case of central tendency, the best average is considered as a arithmetic means, because it is very simple, very structured and is very reliable. And in the case of dispersion, in fact standard deviation is considered as the best technique under absolute measure, but in reality coefficient variation is considered as the best technique, because it is the unitless measurement and it is a relative issues. I will give you very practical examples. Let me let me take a case. What is the exact issue or difference between the central tendency, dispersion and skewness, because there is a beautiful structure and stepwise process. So, now when there is a question of central tendency will give you only positional issue and you can say mathematical issue, but there when there is a question of comparative analysis, then obviously there is a issue where two variables are there and we like to compare the two variables. There may be possibility that the mean of that particular variable is same. So, that means, if x 1 is a variable and x 2 is a variable and number of observations are same or different, then obviously we like to know what is the average of this particular series. Then you can say that this, if the average is high for second series than the first, then you can say that this second is better than first or first is better than second. Okay. Now, the situation will be completely different if the mean of both the series will be equal, then in that case you cannot get any conclusion or you cannot make a comparative analysis. In that case we have to go or you have to proceed further to dispersion. The series may have equal means, but the dispersion will be completely different. So, now equal mean may have unequal variance or unequal standard deviations. So, now only mean cannot be sufficient to represent the univariate structure of econometric modeling. So, you need to have a dispersion. So, variability structure. So, variability will give you the indication or comparative analysis between this series. Again, let us take a case of mean is same and standard deviation is also same for both the cases. Then still you like to have a comparative analysis, and in that case there may be some situation even mean is equal and you can say standard deviation also equal, then still you cannot get a conclusions. So, in that case you have to apply a relative measure of dispersions, or you can go for you can say skewness and kurtosis. Let me take another issue here. Particularly take a case of absolute measure of dispersion and relative measure of dispersions. Yes, of course, there is two different problems. Let us take a case of foreign exchange issues. So, take a case of Japanese currency yen and another case is US dollar. Okay. So, now some of the observations are in yen form and some of the observations are in dollar form. So, now we like to know what is the stability of yen and what is the stability of dollars. So, now to know the stability of dollar and yen, you need to have apply the standard technique called as a dispersion. So, the component stability component will be more stable if the variations or variability is very less. Okay. So, now in the case of say yen, if the standard deviation or variance is very high, then you can say that it is not stable, but in other case if it is say the variation is very less, then you can say that it is stable. So, that means the stability of a particular currency depends upon the variability structure. If the standard deviation is very low, then the currency is a very stable one. If the standard deviation is very high, then obviously the currency stability is currency stability is not too good, it may be negative. So, that means it is not at all stable, that may be instability. So, now in that case the example may be in a different shape. For instance, this is issue how you have to measure the stability, but suppose I like to compare the yen with dollar, which is more effective and more accurate, but in that case sometimes it may be more complicated also. For instance, the moment you will get the result by applying standard deviation for yen and for US dollar, and obviously if the items are represented in yen, then the mean and standard deviation you will get it in yen. But if you have the observation in dollars, then obviously the mean and standard deviation you will get it in also dollars. But if it is a comparative analysis, then the mean which is in mean standard deviation which are in En and other side mean standard deviation which are in dollar format cannot be comparable, because yen and dollars are completely different. There is the foreign exchange market, we can make the distinguish, but in that case statistics is very handy. So, if you will apply econometric tool, particularly coefficient variation or coefficient of quartile deviation or coefficient of mean deviation, then obviously this particular problem can be solved without any additional information. Suppose you have information what is the dollar value and what is the UN value, then you can transfer either yen into yen or dollar into dollar, then you make a comparative analysis. But if you have no information, such information, then you just apply the standard statistical tool, say coefficient variation, then you can get the result. So, this is how you have to be very careful to solve the particular problems, right. So, now we have to move down to another issue. Let me give a brief idea about the structure of individual series and you can say discrete series and continuous series. I have discussed detail about the calculation of mean, median, mode and standard deviations and also coefficient variance, etc. So, there may be some issues here with respect to discrete series and continuous series. So, now there are series of structure here. So, all these structure are almost all same here. Here we are just whatever discussion we have till now, we are just following the particular format, that is individual series components. When there is a discrete component, then obviously weight factor has to be assigned, and in the case of continuous series, then obviously the interval structure must be there, and that interval may be in a particular, you can say, class interval. So, with that class interval and you can say proper structure, we have to calculate the mean and you can say standard deviation or coefficient variation in different way. The complete calculating procedure is altogether different, but the result is almost all same. In the detailed structure of calculation, I may highlight in different class, because it is not possible now to take an example to solve. So, we will discuss in next class the detail about when we will go for bivariate modeling. That time I will explain how it can be possible when the series is in completely a discrete series and continuous series. So, now I will explain one thing here, that is the one other aspects of this particular problem, that is skewness and kurtosis. The skewness issue is nothing but shape of the distributions. So, that is we like to know what is the position of this particular series. So, we usually look for normal distributions. Normal distribution, if it is normally distributed, then obviously the distribution is called as a symmetric distribution, where mean, median, mode are equal. If mean, median, mode are not equal, then this distribution is called as a skewed distribution. It may be negatively skewed, it may be positively skewed. Okay. So, now we need to have, you can say, the structure like this. This is symmetrical 0 skew, and when there is a positive negative skewed, then it is called as skewed distribution. Generally, we look for this structure of data setup. If you have a data setup like this, then obviously it is called as a symmetrical distribution, and that is very effective for modeling or particularly multivariate modeling. If all these variable information is like this, then obviously you are in the right track. If not, then obviously your structure is completely different. If your data setup is not normally distributed, then obviously you have to apply the transformation rule. We have series of transformation rule, starting from exponential transformation, logarithm transformation and fast difference transformations. So, the way you will transfer the data, automatically the series can be transferred into normally distributed. So, this is very important point to. So, this is another shape of the normal distribution. So, now this is positive skewed distributions, and this is what negative skewed distributions, and this is the case for both the distribution altogether, right. So, now last but not the least component under univariate modeling is the kurtosis. It represents simply the flatness of the distributions. There are three different structures. It is the you take it here case is the this is one shape, this is another shape, this is another shape. So, this particular shape is called as a thin structure, this particular shape is called as a flat structure, and this is what is the middle between this thin and flat. Generally, within the setup we consider that this red structure is very beautiful and it is very effective for further modeling. So, this is usual shape of the normal distribution curve, it is usually called as a bell shaped curve. If it is like this, then obviously the structure is very feasible for further econometric modeling. So, with this we have to finish this session here. So, we will discuss detail in the next class for you can say with beautiful examples and different structure. So, thank you very much, have a nice day.